Welcome to this Trimble Business Center video tutorial. In this video we will work with the TBC tutorial data processing DJI aerial survey data. Our main topic of this video is the point cloud generation. In this video I'm using the project I created in the video Tbc Apm full course ground control point measurement. Therefore, I have baseline process GNSS and I measured 3 control points, which are here seen with control point 501, 502 and 503. And we will now go to calculate point clouds for our project. Before we go into our deliverables, let's take a look here at our boundary, which is this US flight mission polygon that we can see here. So this is by default here added to our project when we import our images. And I will now extend here for my images the viewing range. So I will change the viewing distance to our 262 feet. And this is our approximate flying height. And then our footprints or our image frames, they will then be extended to this size. And we can now see that this white polygon, which is our flight mission, is not extended to the furthest part of our images. So we have here an area that is not used, and this has a good reason, because when we have here this polygon where this ends, we have still many multiple overlapping images there. So extracting here a point cloud will then not only be able to use one stereo model, but there are more than 2 or 3 stereo models available, allowing us to generate a more sophisticated point cloud. In case you want to extract the point cloud to the uttermost part outside of your project, then no problem. You can generate yourself just polygons, either importing the WG, for example, or shapefile, or also digitizing them in TBC. What I have done, so I generated here different layers. So first I generated a general boundary, which is this purple line. And because I want now to show here the different results of the point clouds, I subdivided this part into 9 smaller sections. So 3 different for the DTM, which are these 3 yellow ones, then here 3 for the DSM, which are the orange ones here, and 3 for the DSM HQ. And you see that they are here overlapping outside of our footprints from our images. So therefore, there will be areas where we don't have images covering our polygons. I also did for the first one here on purpose here outside, so we can see here how the point cloud will be generated in areas where our boundary is not anymore covered by drone images. So let me blend out the photogrammetric stuff so we can see here these polygons. And for time issues, I already processed this data. So I unfortunately will not make a live show how I process them. I will show you how the parameters have been set, and we will generate it in this way. Let's open here the deliverables. I always here selected for the boundary my polygon, like for example here I chose this DTM low, and then because it's called DTM low, no surprise, I used digital terrain model and I used the low density, and then I created only the point cloud, and then we will see now all the different results. So I generated all of them here, and we will then take a look and compare them to each other and see the benefits, the accuracies, the qualities, and also about interpretation of the point clouds. In this video we will not cover orthophotos, but just to have mentioned it once here, and I will mention it a couple times. If you generate an auto-mosaic, then always, even if you would only check the auto-mosaic box and you would not activate this one, there is a point cloud generation in the background happening. We here automated this process, so therefore if you need an autophoto, then of course create a point cloud and the auto in the same time, so you will see the point cloud that has been used for your autophoto generation. If you want to edit the point cloud before generating the auto mosaic, then you will need to go through US Master, where you can first generate a point cloud, make editing on the point cloud using very nice editing tools in US Master, and then after the point cloud is corrected with elimination of errors and also removing perhaps some obstacles, placing points correctly, measuring some stereo break lines, emphasizing here road or slope changes, then you can afterwards use this point cloud to generate the autophoto from this point cloud. So it's a two-step processing possible also there. This is not possible in TBC, so I generated now just point clouds, but with this point clouds I could not now say only use generate autophotos based on these ones. It means if I would check this one on, it would still run this settings here. It would not write out the point cloud because I did not check it off. So this is writing the point cloud, but it would be generating it based on these settings and then create the autophoto. Okay, so let's start with the first point cloud, which is the digital terrain model with the low point cloud density. And this is the first one because I did not name the first one. This is here the first one. And when we here now activate this part and we go back also to photogrammetric part, then we can see here, I mean, these footprints are only approximate, but just that you get the feeling this is exactly what we knew. It means in our case here, the point cloud was not be able to be processed in this part here because there was no imagery existing here to generate. We can see it here on this part, there was enough imagery, so therefore the point cloud is going outside to this area. The density of this point cloud is, when you hover over it, in this case 120 times the pixel size. In our case the pixel size is 2.15 centimeter, and we can see it here in this slide. That means our point density is 2.58 meters. Let me just double check. Yes, meters. It's a feet project, but the log file is putting it out in meters. So 2.58 meters, so 120 times the ground sample distance, the original one on level 0, which is 0.0215. So, and if I take this value 30 times, we will see later on in DTM high, this will then correspond to a point cloud with a density of 0.65 meters. And on medium, it will be 60 times, so 1.3 meters approximate is our point density. The points are already colorized. When we take a look here also in the profile view, we can see that this point cloud already is representing the terrain. So let's here change, and we can see here, there's my road, here is the hill going downwards, and there is here some smaller undulation in this part here. Let me also switch off my polygons here, so we cannot get disturbed by them here, and also this one here. So there we go. So this is the first point cloud, and we will just add now to this one the second point cloud, which is now in our case here the DTM medium part. So when we see now the medium part, we start now to tend a little bit better to make a better interpretation. So we already can now see in the point cloud better, okay, this is also here a road, this is here a road, okay, this seems to be vegetation a little bit, there is something here on this part here, But more important, of course, is now also here the more detailed description of this change between the road to the slope that follows up, and the same thing also on the other side. And this is now also then giving us here a more detailed height accuracy of our points on the ground. And this is now the next part. So besides the point density, we also have, of course, a difference in the, well, not of course, but we have a difference in the height accuracy, mainly because the GSD on which the point cloud matching was done from low, which was here using ground sample distance of 0.086 centimeters. So we were not matching on the original ones in level 2 on this DTM low, but on level 2. So 1 pixel is representing about 8.5 centimeters. And in the DTM medium, we were matching on the first pyramid level, which represented by a pixel of 0.04. And therefore, our height accuracy became better. So in general, this is a relative value, a statistical value, but in statistics here, because on level 2 with a very low point density, our height accuracy is only around 0.7 centimeters, 72 centimeters. And on the medium, we are reaching here 25 centimeter height accuracy. And then for high, no surprise, we are matching here on the highest part. And therefore here we are reaching now here a height accuracy of 8 centimeters, which is something that we also try to get. It's very common, a factor 4 to 5 times. So if I have this value of a GSD of 2 centimeters, typically the height accuracy that you get is something between 8 to 10 centimeters. And this is exactly what we get. Again, this is about a sigma value, so 3 times sigma also included. So 68% of my data I want to have inside this part, and therefore having this value is also from the base height ratio dependent for the height value, and we are reaching here 4 to 5 times typically for good data height accuracy. On the low part, because our pixels are only 8 centimeter, therefore we have lesser contrast on the ground than what we are matching, and therefore the height accuracy here we see tends to be even up to 8 to 9 times larger, due to, in this case here, lower texture quality of our image. And of course we get more points, no surprise. So for the DTM high we will get here 20,000 points, medium 5,000, and low 1,200 points. And processing time, it's a very small area. We are talking everything here between 1 minute, half a minute, or 10 seconds. So let's bring in then our DTM high, and then this is the first point cloud now where we have now a much better feeling what is now really here, what content. So the interpretation is here of course much better to be done. We have a much denser point cloud here on this part. We see also from the noise, I hope you can a little bit see there are here more jumps in this point cloud here in comparison to this dense point cloud. And also what we have now here is for the interpretation many more informations. We see the middle line here of this road. You can see here very nicely here where the terrain is now here falling, so where we have here this slope change, and therefore this gives us of course a much better interpretation. And also this can already go into volume calculation. So we have now here a point density of 65 centimeter. So this already allows us here for some not too complex, but for some volume calculation to get very good results. Okay, let's go now to the DSM. And for the DSM, we are always using a factor 6, but always from the image level. That means in my case here, my image level is level 2 for DSM low, which is 8.6 centimeters. 6 times this value is in this case 0.517. I used here always the factor in comparison to the original GSD, so 24 times the original resolution of 0.0215 is 0.51, just that you see here, so it's continuing. That means DSM, even the low one, is denser than the high DTM one. Yeah, so we get here already more points for our project. But the height accuracy in this case here is then lower, so that because we are matching on pyramid level 2. So let's take a look at the DSM low point cloud, which would be, if I choose here surface model and here low, and then I created here the point cloud. So this would be my setting for DSM low, and of course for DTM high, I choose here DTM and then here high. So this is just these different settings that we are running through. And DSM low is now much denser already here, and we can now see here in the DSM low already many more details than in our DTM high. And this is now for interpretation, of course, much better. So we have here, of course, first part, of course, is here a very clear and sharp definition already here of our curve. Not perfect, but at least we see already here's our curve. We see the slope very nicely. There's a very good interpretation. We see this is stones, this is now trees. So in the DSM, this gives us a big advantage. And secondly, not so easy to see, but let's see if we can find it out. This is now here a tree, and if I switch it off, we can see that here this point cloud behind is avoiding the trees. So the DSM, it tries to include in the point cloud itself the content of objects, of single objects. So here we can see it a little bit here. Yeah. So we see here the point cloud here is going up, and the other point cloud is here on the bottom. So in general, terrain modeling, so whenever you use here the terrain model option, there is a filter built in that tries to avoid. It's not possible always, because sometimes larger areas cannot be filtered out in an automatic way, but in general the algorithm tries to stay on the ground. And DSM is the opposite. DSM in this case tries to include all these single objects in it. So in this case here, giving us of course also much more details about small things, like for example these stones, or if there would be some smaller objects here also, they would be part of the DSM point cloud, and therefore giving us also here a better real world understanding. And so we can now enhance, so we can go now from our DSM low to our DSM medium. Sorry, this is the wrong one, DSM medium, where we now get an even more denser point cloud than before. And I just give the computer some time to process this part here. So let me here go to this here. That's now my medium. And when we zoom in here, we can now here see the difference in the point density. So this is our medium, and this is our low high. And I'm not sure. Perhaps he gives up. Let me close it and reopen it one more time, and hope that this will then make it possible to see it. Yes, here we go. And we can now see here the even denser medium point cloud. Let me here switch on the Polygon, and then we can see here, I know the Polygon is here having, oh yeah, it should be in it here. So here's the difference, and we can see here now, this is the DSM low, and this is the DSM high. We can see it, for example, here in these driving paths of this truck. So let me here switch this line again off, and we can see in this point cloud them already included better. Here we can only guess it in the point cloud. Yeah? So this is now here the point cloud from the DSM. Next part is then, of course, the highest one, which is DSM high. And DSM high now has now here the highest density, and we can now see here that small objects already here in this DSM point cloud are much better included. Also cars and buildings, they are now with a much higher density included in the point cloud. Of course, this goes together with time and point density. We talked about, we are speaking with DSM high about 3.7 million points in comparison to the 20,000 points in the DTM high. And I blended out this because I think perhaps I made something wrong, because I had the same point density for the medium log file. So this is on my side. But in general, 6 minutes, so about 6 times longer. It's a very small project, so we have to take into consideration, I wrote it down here, this is just about reading the images in this project. So this is already in some cases 50% of the time. At the beginning was just reading the images, and here it's only 10% of the time or lesser. But in general, of course, much larger point clouds, which means also more to handle. That means, do you need this dense point cloud? Is this something that you really are needing to generate your product? If yes, of course, it gives you a huge amount of details also in it. Therefore also much better interpretation. If you use filter functions later on from the TBC, you can filter much better ground and off ground away, because the details are much sharper differentiated. And this is also where we go into the main purpose or idea. So with the DTM, it's a very fast one. It has a lower density, but it's for, if your main goal is orthophoto generation for open terrain area, this is an awesome option to generate very large projects with a even high quality orthophoto. Don't forget, the orthophoto does not need to be in the same resolution as the point cloud. Yeah, so that means if my DTM, let's say high, is here with 65 centimeters with a 8 centimeter height accuracy, I can still generate 3 centimeter orthophotos from it, mainly because the DTM is only used to auto-rectify my digital images, but I can still, of course, use my original, in this case here, DJI image, to auto-rectify it and to make my mosaic out of it. So therefore, we can generate here with a lower amount of points, still a very high, precise orthophoto mosaic with the DTM approach. Of course, if your main goal is then volume calculation, or where your point cloud really is important also to generate further products, if it's, for example, curb extraction, or also digitizing, perhaps using the point cloud as some reference, and still together with an orthophoto, then the DSM is a very nice solution. Also, with the DSM, the orthophoto is somehow like almost a true orthophoto. We are not putting so much emphasis on completely making the building edges perfect, pitch perfect. Also, there's a different technology behind it about extracting the orthophotos from a DSM approach in comparison to the DSM high quality approach. But still, if you just need the orthophoto to verify that behind the building there's a parking lot or there is some vegetation, and to digitize it, this can be for many purposes also sufficient for it. The factor is just 5 to 10 times longer than the DTM that you have to be taking into consideration for this calculation. And then finally, I will now show also the DSM high quality part. This is where we put a lot of effort into the point cloud and into the true orthophoto. So there's multi-matching included. There's also the point cloud itself is the base where we generate a mesh out of it, a DSM mesh model. and where we then texture on this DSM mesh model the images on top of it, so that the true orthophoto really is sharp along building edges, also to avoid along facades that there are some wobbling effects in it, so they look, in this case here, clearer. That means if you would have some texture like windows and stuff like that, then you will see in the DSM HQ that the facades look nicer. It's more perhaps just for visualization, but still for many people important, this part, to have this included. So very important here also, again, 5 to 10 times longer than the DSM. So that means to the DTM, this can be 50 to 100 times longer the processing time. Again, if you need a true orthophoto and you can run it overnight and you say, I don't care, I just leave it on the evening, I come this next morning, and then I have a super good looking true orthophoto, then definitely something to be considered. I will show here shortly just from a wind chart project that I processed how this true orthophoto can look like, and this is really an amazing thing if you want to use it for digitizing, or also to extract out of the point cloud here some features and do some surfacing or do some other TBC related continuous processing parts. So let's take a look at our DSM HQ result. And in my case here, what I have done is now, besides my DSM high, I now place the DSM HQ high. It's not continuing now again low, medium, high, but high, just because we can then compare the DSM high with the DSM HQ high, which is of course for us the interesting part. And then when we zoom into this part, we can see now that the DSM HQ is even denser than the DSM high. And therefore here we have now even more details now, and we can now see the nice thing. Let's go into the 3D view and scroll it here. And we can now see here, there we are. Now here this is really much sharper, less offshots here, and therefore a much cleaner point cloud that we can now use for further processing. So this is really something really nice to consider. Also the bump here is much cleaner, and therefore we even see the small pylons that are here placed in front. We can see it here also on the road, so there's less noise now here in comparison to the other one. You can see here a little bit is wobbling here effect, because the point cloud in DSM uses less stereo models for each matching of a point, and therefore here in this point cloud here, the wobbling is not anymore well, we talk here about centimeter wobbling. This doesn't matter at all. It's just looking cleaner for the other one. And it's a cleaner, less noisy point cloud that you get. And this is exactly what you want when you want to have the best quality. Same is also here for the part here. We have now a cleaner point cloud here along the curb. So we see the curb here in the DSM high is still very nice to see, in comparison to the lower or the DTM, much better. But for the DSM HQ, this is now the highest quality of point cloud that we can extract. That gives us here for many other options, possibilities to generate great products. Also the cleaner point cloud also in complex structure. So here in this forest part, the points are less noisy. It's still a 2.5D point cloud. So if I compare this now here to this point cloud here, this has now many more in-between points. The noise ratio is here much higher. It means if we would run here a filtering for the DSM HQ in the forest, we would have a much higher possibility to really extract ground from off-ground, in comparison to the general DSM HQ point cloud. Mainly because we have all these dropping points here from the trees downwards, they don't exist. This is also called a 2.5D approach of the sift operation that we use here. So we really try to match here the canopy, the top, and therefore the ground. Same would be for buildings. In buildings, you would normally have no points along the facade, mainly because if we detect clear, sharp edges, in this case here, we try to avoid points with the same XY position, which will then afterwards give a much cleaner facade position when you generate meshes, for example, in US Master. But also for the true auto generation. You don't want to have a wobbling facade. You want to have a clear, sharp facade going down, not causing some, in the true auto photo generation, some misplacements in the pixels. So, and finally, let's take a look here at our edge. Perhaps you will remember. So let's go here to these polygons here and also the photo part. So when we now take a look here at our polygon here at the end, we can see here that we still don't match up to the last part here. Mainly because switch this one again off. Mainly because our overlapping ratio is here lower. Yeah? For example, for the DSM HQ, every single point needs to have at least 2 stereo models. That means if there's only one stereo model existing, which will be here in the outer part, these points are not matched. In the DSM, this is not the case. The DSM itself can also match with one single stereo model. Therefore, the point cloud goes outside. But if we look at the quality, of course, we can now see that this is exactly causing here lesser accurate point clouds. I think we can see it here. Here in the background a little bit. Yeah, so it's really, this is not looking nice anymore. We even don't see behind the trees. So this is really falling off. We can also see it in the DTM before. That was here. Let me see it here. Yeah. So here, this is now really dropping off extremely here. If we take a look at the road, here we can see it here. Yeah, so it's not really clean continuing. It has here a little bit of a bump in it. Yeah, so a little bit. And this is really just because it's the lowest part of our scene, hidden behind trees, and therefore not causing the best quality of a point cloud. And therefore also for the orthophoto, not the best one. But you can use it, of course. You can also generate from this part here orthophoto, looking straight down. This would still allow us to generate here from the images orthophoto products. Therefore, no problem also using this one here. So let's wrap up also with the properties. So all our runs, when we take a look here, we can look at the properties. We can now see here. This is represented in this case by these 1205 points, or when we go to the next one here and look at the properties here, 5152 points, or here with the 20,613 points, which is listed here on this slide. So we can see here these values, and the same is also with these values here. We can also find them in the other files. So when I go to my DSM low, to my properties, then here my 1,044,000, on my medium my 3.78 million, and it's, I don't know, I made perhaps a mistake, because then the high is here also around DSM high here is also around 3.7 million. Then the DSM HQ low here, in this case, includes these 973,000 points, and the DSM medium HQ, the 14 million points, and DSM high also with the 13 million. So I don't know, for the medium part I perhaps changed first the output and then the parameter. I'm not sure, or opposite wise. I have to check what I made wrong. But I think it makes sense for you to understand how the parameters are fetched now for this processing part. Okay, so I hope this helped you to understand these different elevation types, the point clouds. You have seen now here the different results, how they tend to generate different outputs, also different density, and also different height accuracy. They will generate different amounts of points, and they will take different amount of time to be processed. They have all their benefits. So for if you are mainly interested in the orthophoto, and also with a high resolution of the orthophoto, the DTM is a very nice and fast product. The DSM for anything you do with volume calculation or with the point clouds, so also mining and stuff like that, really nice. And if you are interested into true orthophoto, or you need a very clean and the best maximum accuracy in your point cloud, then the DSM HQ can really generate this. So it gives you all the flexibility that you need and want for all different amounts of products. So just feel free to use them on your purpose, what you need. And also be aware that when you generate the orthophoto, then the elevation type will always be also processed, even if there is already a point cloud here existing. So if you really want to split this process, you need to go to US Master. Then you can first process the point cloud, edit the point cloud, use the edited point cloud for the orthophoto processing in TBC. Then if you are interested in the orthophoto, always create the orthophoto together with the point cloud. But this will be then covered in the next video, where we will talk just about orthophoto production and also how the point cloud will be then used in this purpose. So thank you for watching and have a nice good day. Goodbye.